Okay, so we're broadcasting now. Yeah, so like when it came to what is question 9B, or is like what is the z-score you would use? I just used my rounded answer from question A instead of using the answer I got from the calculator. And so I was off by like 0.001, or something like that.
Yeah, well, and this is one where you get this last question, you have to get the z value to, determine what's the before and after, so you get the, the b. And again, I'm fairly close, but even just doing, it's strange, and it's weird because a lot of them in these answers, they're going beyond that third decimal, so it's like, I wish there was some consistency, but oh well. It's the way it goes. So.
Yeah, I wonder, maybe it's just because the numbers are so small that otherwise they all end up being 0.000.
Yep. Well, I didn't have any real questions. I mean, I just worked through it like I always do, and like I say, I went to the homework and I was fine on the homework except for that one question. So, I mean, I'm ready to move to the quiz depending on where you guys are.
Yeah, it sounds good to me. I mean, the second part, I'm still a little confused on the relevance of. Like, I understand the equations and how to use them. I don't know if I study a little more on the relevance of them, like why they're important. They just.
Well, I can't figure out why a lot of this stuff's important and whether I'll use it in life. But hey, I got to get through class, so I will.
Well, I was gonna say, like, it seemed like arbitrary, I guess, because if you know because it's like we've moved on past the point already of, saying that, oh, in real world we don't know the actual mean, but now we're back to saying, oh, but now we're solving this when we do know the actual mean.
Yeah.
But it's like, if we know the actual mean, why? Yeah, I am a little confused on I'm not confused on the math of it. I'm more confused on the application of it, I guess.
Well, let's jump to this quiz because we also need to talk. I don't know if you guys had a chance to look at the design the study thing, but we need to at least go over that worksheet and figure a few things out.
Okay. Is that for the project?
Right. Yep. Yeah, this is the first week. We need to start making some
decisions.
I glanced over and I haven't read it in depth, but I did open up the design the study attachment that was on the lesson this week. And
Okay, yeah. I've been out of town, so I didn't.
Yeah, if we just, I mean, it's not due. We have to submit it. Well, technically, I think he sent an email out saying that ultimately he's not due till next week because he has to approve whatever study we do. But I think we have to submit something on it this week, and
right. We at least have to know what our study is going to be.
Yeah, we can kind of glance over it tonight, and then probably make some decisions on Thursday, maybe.
Yep.
Okay.
I agree.
Sounds good. Okay, so let's do this quiz. 16, right? I'll go ahead and start this, and then I'll screen share with y'all. Okay.
We're back to using the normal probability applet again.
Yay. Okay. And 2, done. Okay. So in a pie chart, why are the slices different sizes?
Because some people eat more than others.
Yes. I like that. Yeah. So
I like
see.
Each slice.
It's the each slice represent. I just like the last one. Pie charts are more visually appealing when the slices are different sizes. Yeah, that's about as random as it gets.
unless you're like ADHD or something. Not ADHD, I'm ADD. Okay, so you said it's the third one category in the English.
Yeah.
Yeah. Okay. I just had to read that long sentence. So. Okay.
How are bar charts and Pareto charts related?
It's the last one.
Yep. They're just ordered from largest to smallest.
Okay, cool.
We conclude that P hat is normally distributed if n times a P is greater than or equal to 10, and then blah, blah, blah. Question. Is P the true proportion or the sample proportion?
P is the true, right?
Yes.
Yeah.
N is the number of candidates, is the sample size, the number of candidates in an election. Well, it would be, technically that could be right if we were sampling the number of candidates in an election.
True.
But the sample size would be the appropriate answer.
Yeah. Okay. If P equals 1/4, the smallest n that satisfies the requirement. We got to use this equation up here.
So what's 25% that equals 10? What do we need 25% of? Yeah, you got to put the equation in there and solve for n.
Yeah. So you'd have 10 times 4. So it'd be 40 would be the solution to the first equation.
So 41 minus P. Well, bottom line without even going to the second. Well, I guess we have to go to the second one to make sure that equals it. So P is 1/4. So you got 0.75. 40 times 0.75 is what? 40 times.
Let's see.
5 is 30. So yeah, it's
okay.
going to be 40.
I was confused by where you guys are going with this, but we're using that
Right. So
the inequality at the beginning for that
Right.
question. Okay.
Yeah.
So the lowest number would be the one that NP equals 10.
Yeah. Greater than or equal to 10. So 40 would be the answer.
P. So we're solving for n, which gives us 40.
Yeah, so the sample size of 40 would be the smallest sample size to equal that requirement.
I believe so.
Yep. Okay.
Okay.
Okay, so N is 24, P is 0.4. What's the mean? So this is where we're going to take the, the P hat equals the, wait, is that P, is that P without the hat equal the,
isn't that X divided by N?
Yeah, that's what I think it is.
Yeah.
So it would be the,
so that should be 0.4 times 24, I think.
would it be divided by?
Yeah. Yeah, so
because in this case the P is the X, which is the number of individuals in the sample.
Okay.
Isn't it? Am I right? because we're trying to solve for the mean of the p hat.
Right.
So the p. Okay, what is the mean of sample proportion? It's the population proportion, right? Yeah.
Mean of population is P. All right.
Right.
So that's going to be P. The formula is going to be the p hat equals x divided by n, which the x in this case is going to be that p equals 0.4.
Okay. All right.
Okay. Yeah.
If I understand it correctly, which is we're going to round to the round answer to the 10th place. Well, then we got a problem because the 10 that comes to 0.016, so that's 0. Are we sure we're all right on that? Let's see here. Go back.
Oh, okay. No. So the question: what is the mean of p, which is the sample, and it's the mean equals the 0.4. So it's the same question that was on the assignment.
That's right.
Yeah. So
that's right. There's no formula. You get it from the problem. It's given in the problem.
Yeah, and that relates back to I don't know what lesson it was, but the fact that the sample mean is for the equations is the actual mean, and then we use the other equation to get the standard deviation.
Yeah, we do that's the standard deviation is the p of the p hat equals the square root of p times 1 minus p divided by the n.
Right.
So that being the case, we have, where are you? P, sorry, p is 0.4.
0.4.
So 0.4 times 1 minus 0.4.
Which is 0.96.
Divided by n, which is 24. And you take the square root of all that. Comes to 0.1.
0.1, yeah, that's what I got. Did you follow that, Paul?
So if you have your preparation work open, question 4 was the same thing. So the formula to figure the standard deviation of p hat is the square root of p times 1 minus p divided by n.
Right.
So we're just working through that math. So our p is 0.4. So you're going to have 0.4 times 1 minus 0.4 divided by 24 in the square root of that answer.
Wait. So did you guys move on to number 9?
Yeah. So
yes.
sorry. So
that's where okay.
Number 8 was the 0.4. Then number 9 asked for the standard deviation. Sorry.
All right.
Yeah. So number 8's not a formula, and it's the mean of p is given to us up there in the problem. The p equals 0.04. That's the mean.
Okay.
Of it. It's a given.
Yeah. Okay. I got to get used to the new symbols here. So, all right. Yep. And then I thought now that I know you're working on the standard deviation, I totally follow what you're doing.
Okay. Well, that's good.
So, okay.
All right. So then we got 0.1 for that. The standard deviation. Okay. So should we move on to 10 then?
Yeah.
Yep.
Okay.
So this should be 0.3 divided by 100, right?
No. Brady's batting average is 3. We want you to turn product. She'll get 35 hits in her next 100 at bats. So isn't this going to be the X is the N's 100.
And the X, so then the X is 35. That's how many hits she got.
That's what I think it is, because that's the proportion. We want to know what the proportion. So I think that's right. You're going to take 35 divided by 100. So 0.35. It says rounded 2 decimals. I think that's what we're looking for.
Okay.
The X,
so, yeah,
the
so
X is going to be, the X is going to be the 35 hits in 100 at bat. So the P hat is going to equal the X divided by the N.
Okay. So and that's
35 divided by 100. So 0.35 is what the answer is.
Oh yeah, that makes sense. I was about to put that in my calculator until you said that. I was like, wait, no, that's calculator for that.
So then we're back to the standard deviation one, which again is going to be the square root of P, which is 0.3
times 0.97.
Well, you have 0.3 times 1 minus 0.3.
Oh yeah, right. I was thinking 0.03.
Right.
And then we're going to divide that by 100.
30, or no, 100?
Times.
Yep, the N.
Yeah.
And then we got to do the square root of that, which I get, it wants to 3 decimals. I get 0.0458, so 0.046 is what my calculators come up with.
So wait, so you got 0.0456?
Yeah, so
wait.
So I got 0.0458.
Right, and I got that as well.
Oh, okay, well maybe I did something wrong.
So I think you must, and this might actually help you with your homework question, because
Right, so we're doing the square root of P, which is 0.3, right?
Yes.
Right.
Times 1 minus 0.3 divided by 100.
Okay.
And we got, so that, and that I'm doing that without the square root, so that's 0.0021, and I'm going to square that out. Okay, 0.458. Yep, I must have typed something wrong the first time.
Are you trying to put it all in your calculator?
0.0458, but we got to round to 3 decimals, so that's why I went to 0.046.
Yes. Yeah.
Right, so I was right. I was just talking wrong.
Okay. Oh, I thought you said 0.0456. Okay.
All right, I think we're on the same page there.
We're good. Yeah. Okay.
So now we need to calculate the z-score. So that's going to be the value minus the mean divided by the standard deviation. So first of all, we got the standard deviation. Our value is going to be 30. Our value is 35 or 100? No, it's 0.35.
Yeah, it's the P. It's 0.35.
Yeah. So 0.35 minus the mean.
Which is 0.3, right?
0.35 minus 0.3 divided by the standard deviation, which is 0.046.
1.09 or 0.87. So I got 1.087. What I got.
Not what I got. Not even close. Guys, 0.35 minus 0.3, that equals 0.05.
Right.
Divide that by 0.046. Yeah, I didn't put the point instead of 046. So I got 1.08695, blah, blah, blah. So 1.087 is what I'm rounding to.
Right. Okay.
Wait, what are you rounding to?
1.087.
Yeah.
Okay, I got it. Yeah.
3 decimals.
So I get a slightly different number if I don't round the standard deviation?
Okay.
Well, I'm just going with the rounding because it's told us to round in that question.
Well, but what he's saying though is if we took the 0.046 from the last answer, but he used the full answer for that, right?
Right.
Yeah, which I agree to that, but being that our instructions were to round to 3 decimals, I think we are supposed to use that number because it's the same problem.
Okay.
We're working on the same problem.
Yeah. Well, just out of curiosity, what did you get, Paul?
Well, I kind of, and I didn't even do the full proportion, but instead of putting 0.46, I put in 0.0458 because those are the 3 digits I can remember.
Right.
And I got 1.09. It would be 2 if I were to round to 3 decimal points.
Wait,
and then you guys got 1.087, correct?
Correct.
Okay. Yeah.
Wait. So you used 0.0459? We used?
No, 0.0458 is what I used. Because I remember those being the last 3 digits. Or last 4 digits, I should say.
Okay.
So if it's wrong, I think we'll just know that we can't round any of the numbers, and we'll have to compute it the whole way through. But I think we could put in the 1.087 and.
Yeah, I think we'll be fine just because these are all the same, and they say it around to 3 decimals, and they go step by step.
Often they do when they want specific. Often they've said, don't round until your last.
Correct.
Last part. They didn't specifically spell that out, so I think we'll roll with that. And then if we need to.
Which, when you're dealing with small numbers like this, rounding and not rounding sometimes does. Like big numbers, it's not as big a deal, but small numbers sometimes it is. So then the probability, we need to get our probability applet.
At least 35 hits. Yeah, so we get the applet, we input the z-score of 1.087, and because we're asking for at least 35 hits, if I understand correctly, we would shade the left tail and the middle because that's at least 35 hits, whereas if we go more than 35 hits, we're looking at the right tail.
No, it would just be the tail, because you would be right if we had a z-score of negative 1.087, but we're looking at the positive z-scores. We only want the ones that's because we're looking at are we looking at more than or less than? Sorry.
It says at least.
So I think you're right. I think it would be everything to the left of the.
Yeah, that's what I'm thinking. It's the left
the positive
and the middle.
Wait.
And if you go back and you think about it, her batting average is 300. So out of 100 hits, odds are she's going to hit 30.
Right.
She's hitting 30 times, and she's asking we should get 35 or more hits. If you put that in the probability applet and do those 2 shades, 86% that she's going to hit them. So it all adds up, right?
Well, but here's the thing, though. So our z-score is the 1.087, right? So we're taking stuff. We're saying at least 35 hits. So we're looking at 35 hits and above. And 35
that's
hits
a good point. So
is that point.
Should be everything to the right then.
Yes. Yeah. Because we're not looking at the lower than that. We're looking at that and higher.
Yeah. Okay. I follow that.
With that.
So we're looking at everything to the right of the tail, the right tail.
Yes.
So you think it's only the 1385?
Yes. Because everything.
What is the probability she gets at least 35 hits?
Yeah, so at least, so it's saying 35 or higher, where 35 is that line right there. So you want that line or higher. So you're looking at the lower side.
Okay. Yeah, we're thinking she gets 35 or more because it's at least 35 hits. So she's got to get over that mark.
Yeah.
Okay. So it's going to be
139. We're rounding up.
Yep. Yep.
Yes. Okay. So here we have the true population proportion and n.
To determine the probability of the results survey of the candidates losing the election, getting less than 50% of the votes. So the standard deviation, we have to first calculate. It's funny because they should just let us do this step by step and give us credit for doing all the steps to get to the question.
So doing the, oh wait, I was going to do the z-score calculation. Never mind.
Yeah, so this is going to be the square root of p times 1 minus p divided by n is going to give us the standard deviation. So we're going to take our p, which is 0.52. We're going to times that by 1 minus 0.52. Divide that by our n of 2,000. Then we're going to take the square root of all that answer. And I come up with 0.01117. So 0.011 is what I come up with.
Yes, that's what I got as well.
Okay, that's what I got.
What z-score would you use? So now we're back to the z-score question, which again is going to be the value minus the mean divided by the standard deviation. So our value is going to be, it's getting less than 50% of the vote. So our value is going to be 0.50.
Right.
Minus the standard deviation divided by, or did I get that wrong?
Minus the mean.
Minus the mean. So our value is going to be 0.50 minus our mean, which is
0.52.
0.52.
You can divide that by the standard deviation we just got.
Divided by 0.011. Negative 46.77. Does that seem right?
I got negative 1.81.
Yeah, I did my math wrong. I was going to say that did seem right. 0.50 minus.
Yeah, I got negative 1.81. Or I guess
818, I guess, technically.
Yes, yeah.
All right, what am I doing wrong here, people? Hang on. The value minus the mean divided by the standard deviation. So we have the value is 0.5
right.
minus 0.52.
Right.
Divided by 0.011.
Why is my calculator not doing this right? What am I doing wrong?
It could be the order you're putting in your calculator. Because if you just type it in, it's going to divide your second number first and then add.
Okay, so I want to take the value, which is 0.5 minus 0.52. And then I want to take that number and divide it by the standard deviation, 0.011. Is it a negative 1.818118?
Yes.
Yes.
Okay. Thank you.
So that is what was happening. It was the calculator giving you the wrong order of operations.
So negative 1.8.
1.8. Yes. That's what we have.
Sweet. All right, so what is the probability? The results will show the candidates losing even though the true is 0.52.
So we need the tail to the left of negative 0.818.
So negative 1.818. Go on to the left. So I come up with 0.0345.
That's what I got.
And we're rounding to three numbers. So 0.035.
5, yeah.
Right?
Negative, right? Wait, no. It's a probability.
So the probability is always a positive number.
Yeah. So negative 0.035?
Positive.
Yeah. Oh, yeah, right. Okay.
Yeah.
0.035.
Don't let myself confuse myself. All right.
That's
Hey, I confuse myself all the time, Paul.
All right.
Unless you want to distort space-time or something, you're not going to go negative.
All right. I'll go ahead and submit this time. I think it's probably my turn.
Okay.
So submitting. Survey says we are 100% correct, folks.
Oh, that's great. I wasn't very confident about this one.
Yeah, the only reason I was feeling better about it is just because it said to go, and I get it because at the top it says do not round until your calculation is complete. But what we learned too is that there's actually a variance in the answers. So as long as our answer falls in that variance, it'll give us
that's good to know.
answer. We learned that from that one assignment that we asked Brother Greenlaw what the deal was. His response basically was there is a variance in there. So.
All right.
As long as we're within that variance, because some people are using SPSS versus Excel and they get different results as well.
Right.
So as long as we're in that variance, we're correct.
Okay.
So that being said, let's take a peek at this design the study directions. So I highly, just between us, recommend that we don't do a survey. Otherwise, we have to do extra work.
Right.
And we have to get it approved. So, and I don't want to go out and ask people questions. So I highly recommend that we stay away from surveys.
Yeah, that sounds fair.
Should I stop recording because we're done with the actual group meeting, right?
Yeah, you can stop recording because we're done with